Here we go, example 6. In how many ways can a first and second place winner be chosen from a contest involving 5 people? Let's just go ahead and name them again. We got Antoine and Bernie. I'm now making up the A, B, C, D, and H. But let's just go back to these 5 people right here. And we want to get a first place and a second place winner. We don't care about third, fourth, and fifth. We only care about first and second. Okay, so all we care about is first place and second place. And you can really see where this is going. This is very similar to what we were just doing. So how many options do we have for first place? 5. There we go. We just got a first place winner. It was Bernie. Bless his heart. How many options do we have for second place? 4. Multiply those. There are 20 different possible first and second place winners. Now, I want to say something that will come in handy later in this lesson. The order in which they come is very important. And that's going to lead us, flip the paper over now please, that's going to lead us to the definition of permutation. I know I'm skipping example 7. I'm doing that again, I apologize. But I'm doing that because it's important that we understand the fundamentals of what this means before we go back to example 7. Because if we did example 7, we would be writing out a lot of unnecessary stuff. And I want to go ahead and show you the shortcut before we get to that stuff. So here goes. The definition of a permutation. There are a lot of mathematical definitions for this. Okay, so if you go into higher mathematics and you realize, I just lied to you, there are several different meanings for this word, but this is the one we're going to go with. It sounds kind of technical, but it'll make sense. It's an ordering. Means we're going to put some things in order. I'll say something right here while you're writing. The word order is going to be incredibly important. There are several synonyms for order that you need to look for in these word problems. We'll talk about that later. But the order of the numbers is very important. It's an ordering of a set of distinct, that word's going to become important later in the next lesson, distinct objects. And usually, and for our purposes it will be all the time, usually it's going to be when ordering, handwriting just got really sloppy all of a sudden, when ordering a smaller group of objects from a larger group. A smaller group from a larger group. Okay, let's compare it to the example we just did. Excuse me. When we compare it to the example we just did, we had 5 people. We only cared about 2 of them. We had a large group and we made it smaller. And that's going to be one of the key things that you're going to look for in word problems that deal with permutations. Large group made smaller. So let's go to example 7 now. In example 7, you have this example of American Idol, and they would narrow it down to 24 people. They'd get all those people, and they'd get down to 24. And then people would start voting. And what they would do is they would have the top 12 contestants. But let's suppose we're going to rank the top 12 contestants from this group of 24. So we have a large group made smaller. So based on the way it's worded, how many ways can the top 12 American Idol contestants be ranked? Ranked is another way of saying this. We're going to put them in order from a field of 24 contestants. Now, there's the long way and there's the short way. Here's the long way, and we're not going to finish it. The long way is going to be, we could have our top contestant, which comes from 24 people. We could have our second best contestant, which comes from 23 people. We can have our third best. You see where this is going. And this is going to be a longer process. 1, 5, 6, 7, 8, 9, 10, 11, 12. And we're going to get all the way down to 13 here. And we're going to have all that. And we're going to have to type all this mess in our calculator. And it's not worth our time. Here's the shortcut. I'm just going to put some dots here so you know you can figure it out. There's a pattern, obviously. But there is a shortcut for it. and it's called NPR in the calculator. It's not National Public Radio. But it's a permutation. And it's going to look like this. I'm going to erase this definition here. It's going to be a little n, a big P, and a little r. Now, in mathematical notation, it's written several different ways. Within this problem, we are going to put the 24 here, and then the 12 here. So whenever you're doing this, you may want to scribble this on your paper somewhere over in the margin or something. This is going to be the large group. Large looks like lange. Large group. This is going to be the small group. And we're going to put it in the calculator like that. You can't just use the letter P, though. Let me show you. I told you that most of what we're going to do on the calculator is going to come from the math menu when you go over to PRB. So here goes. We start with 24. With this particular problem, it starts at 24. So 24. Press math. Go over to probability. See that NPR right there? And while we're here, take a look at that. NCR, we're about to use that one too. Just saying. 24. NPR, and then 12. When you hit enter, it's going to do all that stuff in red right there on the board that I didn't feel like doing, and you didn't either. There you go. Now we got this answer that's going to be in scientific notation. Notice the E. I'm about to write this on the board, but basically it's 1 point, we'll round that to 3. 1.3 times 10 to the 15. That's enormous. That is a very large number. The calculator gave us this, 1.295 in decimals, times 10 to the 15th. We could put 1, 3, and then a bunch of zeros after that if we wanted to. That's going to be sufficient. That is a huge number. Consider, though, you just multiplied 24 times 23 times 22 times 21. That's really what it just did. Okay. I want to recap a little bit here. So let's recap. That's a joke. When you're looking at a word problem, it's going to be a permutation if it is a large group made smaller. 24 people, but we only care about 10 of them. And we're going to put those 10 or 12 or whatever it was, we're going to put those people in order. Group of 5 people, we only want to know what happens to 2 of them, and we're going to put them in order. Large group made smaller, and we're going to put them in order. So what if we don't put them in order? What's it called then? It's called a combination. And that's the next definition on your paper. So let's write it down. A combination is very similar to a permutation, but now we don't care about the order. So here it goes. Combination. This one's kind of a technical definition too, but it's a grouping. So we're going to put things in groups. A grouping of a smaller set of objects from a larger set when the order is, this is so vital right here, when the order is unimportant. When the order is unimportant. There we go. That leads us to our next problem. Example number 8. I'll give you a second to write that though. I'm about to erase this so I can make room for number 8. So make sure you got that. Pause this if you have to. Okay, here we go. Example number 8. It's going to be a combination. So how many different subcommittees can be made from a committee of 5? And there will be 3 people on the subcommittee. So how many people do we have to start with? Big group? 5. Not a very big group, but that's our big group. and we want groups of 3. Let me give you just kind of a brief rundown of what this really means. We have 5 people on committee. We'll call them Elmer this time. We won't use the H. So we have A, B, C, D, and E on a committee. But we want a subcommittee. We want a smaller group of 3. I could put these 3 together. 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 Spells A's. That guy's A. Let's see. I could put these 3 together. I could put these 3 together. Oops, that's a D. I could put these 3 together. I could put those together. And see, I'm gonna figure it out. I'm gonna do this. Oh, I got it. A, C, D. Sounds like a band. And there's one more. Oh. D. Now I could put those 3 together. And the order doesn't matter. See, because you could say, well, I'll just put these 3 together, C, D, and B. Well, B. Sorry, I forgot my letters there. Yeah, I could put those 3 together, but it's the same group as this. They're just in a different order. And if the order is unimportant, if it's just a committee of 3 people and nobody's in charge, then the order doesn't matter. These are the same group, so I'm going to erase this. So if I have 5 people and I want to put them in a group of 3, I want to know how many different groups of 3 are possible. And here they are. Now you can count, there's 10 of them. But if I would have given you a ridiculous problem and said there are 20 people and we want all the possible groups of 2, we don't have time to write all that. So there has to be a shortcut, and obviously there is. Otherwise we wouldn't be doing this right now because we don't have time. So let's mark this out. We have big group of 5, small group of 3. We know the order is unimportant, so it's a combination. In your calculator, you're going to use the little thing called NCR. Same as with NPR. The N is the big group, the R is the small group. Same kind of idea, same way to get to it on the calculator. Here goes. So you press math, go over to, oops, don't do that yet. Put your big number first, put 5. Math, probability, NCR, 3. There you go, there are 10. Calculator will do it for you. We have 2 more examples. They're not going to take long at all, so let's get this done very quickly. When you look at example number 9, it's important that you count correctly. So here we go. You have a collection of toys you're going to donate to the Sunnyside Daycare. Buzz, Bullseye, Jesse, Rex, Mr. Potato Head, Ms. Potato Head, Ham, Slinky Dog, and a green alien. There are 9 of them. So wherever this problem is going, you know you have a large group of 9. 4 of those are going to be placed in the butterfly room. The rest are going to be in the caterpillar room. How many different groups of 4? Order is unimportant. How many different groups of 4 are possible for the butterfly room? We have a large group of 9. We have a small group of 4. You can type that in your calculator. Press 9 first. I want to write down the steps for the calculator. You'll press 9, and then you'll press math, and then you'll go to probability. You'll go to that menu right there. And then you're going to go down to the one that says NCR. Choose that. You'll hit enter on that, and then you'll do 4. You'll press 4. And when you do that, you get your answer. By this point, you might already have your answer. There we go. Okay. I put number 10 in here to prove a point, and it's a very minor point, so I'm going to go very quickly, but I think it's important to note. For example 10, same problem, but now we want to know how many people go in, how many toys go in the other room. Well, we have 9, and now we want a group of 5. So if we have 4 going in this room, we're going to have 5 going in the other. And if you were to follow those same steps, something very interesting happens. And it is not a coincidence. There's a long mathematical explanation for it. Not going to go into it right now, but I think it's interesting. If you press that, get it in your calculator. Hopefully by now you have an answer. I'm going to wait on you. There we go. Same answer as before. Not a coincidence. Here's the deal. Notice that 4 and 5 both add up to be 9. So whatever you get for one, you're going to get for the other as long as these two numbers add up to be that. If there are 126 groups of 4, then when I put them in those groups, I'm going to have obviously groups of 5 that are left behind, and it's going to be the same amount of groups that are left behind in that. Okay? All right, in each box we're going to write down the keywords or phrases that would indicate its use. We will do that in the next video.